So we're now going to look at the next pages of section 3.1, in which we're actually going to solve some linear inequalities rather than just converting them into interval notation and graphing. So since we have to first manipulate some of these expressions using algebraic methods before we can go ahead and graph them, we have to keep in mind that when you're solving an inequality, it's just like solving an equation, as if it had an equal sign, but just treat that inequality symbol as if it was the equal sign. Keep bringing it down as you go step by step throughout the problem. And then once we get it down into a single variable expression, then we can turn the inequality into an interval and graph it like we did on the first page of section 3.1. So in our first example here, we have a parenthesis, in which case we have to imply that there is multiplication in between this -3 and that parenthesis. And that tells us we would then need to distribute this -3 into that following parenthesis to multiply it by each term. We have to do this before we can start worrying about getting all of our x terms on the same side. We first have to clean up this left-hand side by doing the distributing. So by multiplying the -3 by each term inside this parenthesis, the result is -3x minus 12, then bring everything else down. Greater than or equal to 7 minus x. So there's our first step, just distributing the -3. And because it is a -3, it's going to make the x term become negative, and -3 times 4 becomes a minus 12. So now that we have gotten rid of our parentheses, we can approach this by trying to get all of our variable terms on one side and all of our non-variable terms on the other side, and then combining them. So we have an options with our two x terms. We could either try to cancel out this -3x on this side, or cancel out this minus x over on this side. Doesn't really matter which way you approach. To keep the x terms on the left, I'm going to cancel out the minus x over here. So in order to cancel out a minus x, which is the same thing as thinking of a -1x, we can add an x to that side. And then again, because we can treat this just like it's an equation, I had a lot of students that like to do this. They draw a dotted line down from their inequality symbol to remind themselves the two sides in order to keep balance. Right now we have something balanced, so if we're going to add an x on this side, we have to then add an x on the other side. And then go ahead and combine. So a -x plus x, that cancels each other out, which was our whole goal. -3x plus the 2x, or sorry, -3x plus a single x gives us a -2x. So we get -2x. We can also combine like terms here. The -12 plus the 2 will give us a -10. Drop down that greater than or equal to symbol just like it was an equal sign. And then over here, all that's left on the right-hand side is a 7. So, first step, we got all of our x terms on the same side and combined. Now we want to get our non-variable terms onto the same side. We got to get rid of this -10. The opposite of subtracting 10 would be adding 10. That will cancel those 10s out on the left-hand side of the inequality symbol. But again, because it's a balance, whatever we do on the one side to remain balanced, we have to do to the other side. So we have to add 10 to both sides. On the left-hand side, this will cancel out the 10s, leaving us with just the variable term, the -2x we can bring down. Greater than or equal to still remains. 7 plus 10 gives us 17. So one last step in solving this inequality for x is to get the x completely by itself, and right now it has a coefficient, it has a number out front attached to it, a -2. We can always get rid of a variable's coefficient by dividing by that exact coefficient. So if we divide on both sides of this inequality by -2, it will cancel out the -2's on this left-hand side and give us the x by itself that we want. Okay. I'm going to bring this up here. So as I said, the -2's will cancel each other out. we are left with x. 17 divided by a negative 2 gives us a negative 8.5. But I'm not drawing in the inequality symbol yet because that's the one thing that's different between an equation and an inequality. If you have an equation, it's always going to be the same equal sign. With an inequality, if we divide by a negative, you have to remember to flip the way that inequality symbol is facing. So instead of a greater than or equal to symbol, it now flips and becomes a less than or equal to symbol. And you might want to make a little note of that so that you remember why you did that in case you forget when looking back. So flip the inequality symbol and you need to do this whenever you multiply or divide by a negative. Okay. Flip that inequality symbol. So that's why it's a less than or equal to negative 8.5. So now we have this in the form we want it, a basic inequality, single variable by itself. Now we want to convert this into the interval notation we were doing, just like we were doing on the other side of 3.1. And then once we have that, we can also graph it. So if we have our inequality reading x is less than or equal to negative 8.5, that means the biggest x could be is negative 8.5, and it can be anything smaller than that. So writing this in interval notation would mean that it can go down as small as, well, it can go as small as forever. There is no limit. So it will approach negative infinity. The biggest it will ever be is negative 8.5. And in this case, we have a less than or equal to symbol. So it is a bracket around that. Last part then, it would be graphing this. On a number line. So here's negative infinity, positive infinity. We're dealing with negatives and below, so I guess on our number line, all we really need is negative 7, negative 8, negative 9, and negative 10. So according to our interval, x can be negative 8.5, which is going to be halfway in between 8 and 9. So that'd be like right here. And then it could be anything smaller than that or